Section 10.2, Understanding the Thermodynamics of Ion Formation and Solvation. On the left, you see that sodium plus and chlorine minus are surrounded by water molecules. Looking closer, you'll find this oxygen in water are closer to sodium plus. The hydrogen in water are closer to chlorine minus, simply because oxygen is partially negatively charged. Hydrogen has partial positive charge. So this is another picture of sodium plus surrounded by water molecules. So in the first solvation shell for sodium plus, I think there are roughly 10 plus minus water molecules. The enthalpy of solvation of sodium chloride in water may be considered the sum of the following steps. So if you dissolve table salt in water and you are interested in calculating the enthalpy of solvation, well, you can use the information for the following 6 steps to calculate the enthalpy of solvation of sodium chloride. So first, you need to break some ionic bonds in sodium chloride solid to produce sodium atom gas, chlorine gas. I think you can do this step by heating up sodium chloride to make this atoms in the gas phase. And then you look up the ionization energy of sodium and electron affinity for chlorine. To dissolve the sodium plus and chlorine minus in water molecules will have to make some space to accommodate those ions. This step increases the surface area of water and thus requires energy. Why? Because some hydrogen bonds will have to be broken. And then over here, you can just put this sodium plus in the gas phase in the cavity surrounded by water molecules. So this step can be computed. This is just attraction between the sodium plus and the surrounding water molecules. And similarly, you put this chlorine minus in the gas phase in water. So if you sum up the enthalpy change of this 6 steps, you will be able to get the enthalpy of solvation of table salt in water. Not just enthalpy, because Gibbs energy and entropy are also state functions. You can also break down the solvation of sodium chloride into these steps to determine the Gibbs energy of solvation or just any other state functions of solvation.